Hi, I'm Dr. Olathe McIntyre, and I'm a scientist here at Science North. The need to adopt a carbon neutral or even carbon negative economy has been recognized. Phasing out fossil fuels and adopting renewable energy technologies is one way we're reducing our carbon emissions. However, these technologies need to be scaled up, and we need to reinvent the way we generate, store, and distribute energy. And most of all, we need to use less energy. Now, generating and storing energy on site and using a microgrid like Science North does make renewable energy sources more economical. That's because when we generate electricity at a large central station, it needs to be distributed over the national grid of electrical wires. That grid is costly to maintain, and it has transmission losses. So you've probably noticed that maybe about 40% of what you pay for your electricity is for transmission losses and distribution. Transmission losses vary from about 6 to 10% of energy used. They're caused by resistance. Resistance is the process by which a current traveling through a conductor releases heat. So if you imagine this tube is an electrical wire, and this water is 100 joules of electricity, as the electricity travels through the wire, some is lost. That's the heat caused by the random movement of the electrons inside the conductor. Now, resistance varies depending on voltage, conductor, and length of the transmission line. So what do you think is going to happen if I pour my 100 joules of electricity through a longer transmission line? More is lost. Electricity with a higher voltage also moves more efficiently through a line. That's why we see high voltage power lines running over longer distances. And wires that are thicker also offer less resistance. So picture a 4-lane highway versus a 1-lane highway and the same number of cars trying to travel down them. Now, underground wires don't need to be as light as overhead wires, so they can be thicker and more efficient. They also cost less to maintain, and they're less susceptible to severe weather. So that's one way to make a more efficient grid. But not all communities are on a grid, especially in developing countries. And the technologies being adopted by those communities, such as biomass cook stoves or micro solar systems that power lights and charge small electronics, or even slow cooking technologies, such as a bag that seals in heat, are all technologies that we could scale up and integrate into our economy. One renewable energy technology that we have scaled up is a wind turbine. So I have one here. If only I had some wind, that would make this demo a lot better. But, thanks. So as the blade turned, it spun a magnet inside a wire coil. And that is the mechanism behind the generation of all electricity, except solar voltaic. Now, the challenge with wind and solar energy is that we can't control when and how much energy or electricity is produced. So we need storage solutions. Now, lithium-ion batteries, like the ones on our smartphones, are really helping. And liquid metal batteries and other ways of storing potential energy, such as pumping water up during an off-peak time when we don't need the energy, and then letting it fall when we do need the energy, are all being explored. So energy storage innovations are going to help, as will generating, storing electricity on site and using a microgrid. But the most important thing we need to do to be able to phase out fossil fuels is to adopt efficient technologies such as insulation, LED lights, and solar hot water heaters that will allow us to reduce our overall consumption of energy.